What if we don't know if the data is normal? Well, one way is to check to see, does the data approximately match the 68, 95, 99.7 rule? Okay. So here are 77 data points. They've been put into a dot plot for us. Now, if this data is normal, then we know that approximately 68% of all the data will lie within one standard deviation of the mean based off of the 68, 95, 99.7 rule over here on the left. We know that approximately 68% of the data falls between one standard deviation of the mean. So if we put this curve over the top of, we know that the mean was 106. And we also know that the standard normal curve has a mean of 0. So if I put this curve over the top, I'm going to count how many dots are within one standard deviation of the mean. So how many dots fall in this range? Well, I don't want to count them all, but we did it earlier. It's 63. So 63 out of a total of 77, that's 81%. Is that approximately 68% of the data? No way. 80% is not close to 68%. This should be approximately 68%, but it's not. Now we know that approximately 95% should be between two standard deviations. So 95% should fall here. Well, that's 71 out of 77. That's 92.2%. Is that approximately 95%? Kind of close, but not really. Okay. And then we know that 99.7% should fall within three standard deviations of the mean. And as we can see here, that all the data does fall within three standard deviations of the mean. Therefore, it's 100%, which is close. However, this data is not normal because it does not meet the 68, 95, 99.7 rule. 68, 95, 99.7. This data set does not approximate that. Therefore, it is not approximately normal. Okay. This way sucks. Way too much work, way too time consuming. You probably would not be asked to do this to assess normality. Okay. However, you need to understand that that is one way to decide if the data is normal or not. We're going to do assessing normality most of the time using technology. We're going to use our calculator. All right, how do we figure out if the data is normal or not? We're going to make what's called a normal probability plot. Okay. Oftentimes they'll refer to this as a quantile plot. Basically, it says this. If the normal probability plot is approximately linear, approximately makes a straight line, then the data is approximately normal. You're going to like this way to assess normality much better because all we're going to do is put the data in the calculator, hit a button, and decide, is it a straight line or not? If the normal probability plot is approximately linear, then the data is approximately normal. That's what we need to understand about a normal probability plot. So if we come back to our friend, the calculator, you guys are going to really appreciate the calculator in this class. If you don't have one by now, get one. You're going to be in big trouble without a graphing calculator for this course. Okay, so in stat plot, we have a whole bunch of different plots in here. Right now you can see we only have plot 1 turned on. So I'm going to go into plot 1. And this very last plot here, go all the way over to the one that looks kind of like a set of stairs, and I hit enter. That is the normal probability plot. And it's going to ask me, okay, I'll make this plot for you, but where's the data? Well, we already put all of our data in list 1 from the test scores. Let's see if the test scores from our first quiz or our first test were approximately normal. So after adding all this data, we're going to go in again to second y equals, which is our stat plots. We're going to go into plot 1, and we're going to tell it to make a The one that's highlighted is one that's going to do. And we want to use the data in list one. Now we're just simply going to tell it graph. Uh-oh, I don't see it very well. Well, that's very common when we're using this. And they have a special zoom in our calculators for statistic graphs. So if you go to zoom, and then you can see number 9 is zoom stat. I call it stat zoom, zoom stat. So we always in this class will do zoom 9. Hey, it fits. Now, does this look approximately linear? Yeah, it does. I mean, there's a few little wiggles and squiggles in there, but overall, it appears to be linear. Therefore, if the normal probability plot is approximately linear, then the data is approximately normal. So we can say, yes, the data from our test scores is approximately normal because the normal probability plot is approximately linear. Everything in this chapter was about relative standing, describing a distribution. Where do you stand relative to everybody else? So we have to assess normality. Is it normal? Hopefully they tell us. Do z-scores, draw your normal curve, 1, 2, 3 standard deviations after we've standardized it. Percentile is what percent of the observations are less than your value.